Okay, perfect. Got your camera off. Good morning. Welcome to the University of Wisconsin-Milwaukee's Connected Systems Institute lecture series. My name is Charles Mosley, and I'll be your host for today's conversation, the Open Standards Application Form Explained, presented here today by Gary Martz and Darren Blue. Before we go to them, a word from our Executive Director, Mary Bunzel. Mary?
Charles, thank you very much. And thank you very much, Darren and Gary, for contributing your knowledge and insight in this area of standards. You know, just a couple of days ago, I was talking with Don Bartusiak, and it was in the context of connecting him to another gentleman who was trying to drive standards in another industry, the pharma industry. And it just illustrates that the best practices that this project has paved for us are starting to expand into other markets. And it's super important to industry because it opens a whole world of collaboration that is entirely required as we're going through such an exploratory and transformative time in our period of growth. So I want to thank Darren and Gary again for your contribution. So I'll turn it back to you, Charles.
Thank you, Mary. As Director of International Standards at Intel, Mr. Martz is responsible for facilitation of international technology collaborations and standards. Mr. Darren Blue serves as Intel's Director of IoT Strategy. He leads the Industrial Solutions Division of the Intel IoT Group, focusing on business strategy related to smart manufacturing and bringing computing to the edge. Before we begin, everyone, a little bit of housekeeping. Please mute your mics. Enter questions in the Q&A chat box, and we'll ask them as we go along. And afterwards, we'll have more time for your questions. All right, Gary, Darren, take it away.
Hey, thanks, Charles. Thanks, Mary. Thank you for your invitation. I'm very glad to be invited to speak today and present. I've been fortunate to have a fairly long career at Intel, and I've done many jobs at Intel over the years, and currently in my role driving international standards for the industrial segment, I can say that I haven't had this much fun in a long time. My undergrad degree is in industrial engineering from the University of Washington. I spent my first few years at Intel actually using that degree as a manufacturing engineer. Then I went on and earned my MBA at the University of Michigan, came back to Intel, and did a lot of different things, like I said, and then ended up back up in the industrial group. So I've kind of reconnected back to my original studies as an undergrad. And in fact, I've even spent a lot of time now reconnecting with the university and mentoring industrial engineering students as they finish their degrees and begin their job searches. And just a little about me, I'm also a husband and a father of 2 young boys. And the students that I mentor, I often joke with them that they're just practice for when my boys get their age. Few things. It's clear that it's no longer business as usual. I attended Alibaba's IoT Cloud Conference in China a few years ago, and due to a misconnection I had a morning flight from Hong Kong to Hangzhou. And this was the first time that I actually flew over mainland China during the daylight. You know, as part of our jobs, we're at the forefront of change. But as I looked out the windows, I was blown away as what I saw on the ground: infrastructure, rail, power. It was all there and almost nonstop my entire flight. You know, almost all of it was brand new. And today, you know, the average age of a company is less than 12 years old. Not too long ago, the average age of a company was 60 years old. This is probably, you know, folks say the least amount of change we're ever going to see. Things are going to keep accelerating, and the swift business change is driven by technology and advancements in technology. A little story to get us started. This is the evolution of the phone. Some of this history I've lived, Darren lived, Charles, Mary have lived. A lot of the students that might be listening to this, this is probably ancient history. Alexander Graham Bell developed the telephone in 1876. It was a lab experiment that became a commercial product. In the 1930s, the introduction of the phone that me and my colleagues knew as kids, but our kids and most of you don't know what it is. I was actually listening to a keynote from a researcher a few years ago, and he was telling a story about being in a hotel room with his 3-year-old daughter, and he was in the hallway still, and she was in the room, and she was frantically excited. Dad, 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 what is this? And he went over, and she had picked up the phone on the desk, and it was the dial tone. She didn't know what a dial tone was. In the mid 80s, we got mobile with the Motorola Dynatac. And in the mid 90s, we were introduced to the BlackBerry, and this was the first time there was actually a full keyboard on a phone. And finally, what most of us know today was the iPhone in 2007. In terms of utilization of the network and the impact to existing business models, the iPhone was an absolute game changer. And this was a major inflection point for the telecom industry. And this data, this graph, it illustrates some of the dynamics that were going on. With the iPhone and the other smartphones, operators faced a serious networking challenge. Instead of just voice, we had voice, data, and video all increasing at a dramatic pace. And each little red notification on your phone from each activity was actually completely setting up and tearing down a call. And this had a tremendous impact on the network. Where the average revenue per user was flattening, the traffic was exploding, and this required increased investment to build out the infrastructure. The obvious challenge the operators had to address was how to reduce their CapEx and OpEx while improving the performance and user experience. The operators had to completely transform their networks, and they focused on 3 distinct areas to overcome the limitations that they were facing. The first was workload consolidation. The industry used a fragmented set of technologies. One operator noted that at one time they had at least 9 different silicon architectures they were supporting, different tools, different skill sets, limited flexibility. And they had to achieve it. They had to invest in the technology to achieve a goal that they had of 4-to-1 consolidation of workloads. They also virtualized applications. The operators focused on key advancements in IT technologies and decoupling the software from the hardware. And then the third was the operators developed software-defined solutions to separate control and data. This simplified provisioning and management, reduced operating costs, leveraged scale technologies, and improved traffic control. The common drivers were convergence, open interoperability, hardware-software decoupling, intelligence shifting to software, and demand from end user companies. The sustained industry effort is what led to success in the creation of the mobile network that we all enjoy and are able to afford today. So graphically, this is what happened. The telecom industry transformed from proprietary, specialized, monolithic hardware and software applications to standards, open, and interoperable hardware and software solutions. We came away from this effort with a number of key learnings. First, it didn't happen overnight. This was a 10+ year transition and counting. Standards were a key foundational driver. The entire industry was transformed, and the startups and new entrants acted as disruptors. But this telecom network transition isn't just a good story. These same learnings apply to the transformation that's already begun in industrial verticals. And another brief lesson in history that's more relevant to what Darren and I work on today. In our opinion, the current area of industrial IT will send us on a path of economic benefits that could far exceed all the other areas of industrial revolution combined. The first industrial revolution was in the late 1700s when we went from hand tools and basic machines. We increased productivity, increased variety of goods, and reduced cost. And the main drivers here were the steam engine as a critical innovation, as it powered many of the machines in the new factories and also powered boats and locomotives, which helped expand the supply chain. Then if we fast forward about 100 years, we get to this second industrial revolution. Here we saw the introduction of electricity, petroleum, steel, and the assembly line. We decreased production costs and increased volumes. In 1924, Ford produced 2 million Model Ts, and they retailed for less than $300 each. More currently was the third industrial revolution, which was more of a digital revolution. The mechanical and analog solutions that we're using transition to digital electronics like personal computers and programmable logic controllers. The three elements that came together to spark the third industrial revolution were computers, IT, and automation. And this led to massive growth in productivity in many industries. And today we're just at the beginning of the fourth industrial revolution. This is about industrial IT. And this is having devices that are connected, smart, and autonomous. And it's driving the change that we're experiencing now. When we talk about industrial IT and we talk about connected, this means enabling all devices and sensors to share data over a network. Everything can be instrumented, and this has been in progress for many years, and we now have many proprietary protocols providing these solutions. Once devices are connected, we need to make them smart. Machines and groups of machines that can self-optimize and structure for the best outcome, utilizing common sensors and data to drive higher utilization and yields. And this phase ultimately requires a common networking solution and standardized ways to share data and to ingest data. And then finally, we'll move towards complete autonomous solutions. This is technology that can analyze and act by itself. Right now, we've mostly completed the connected phase. We're right in the middle of the smart phase, and the autonomous phase isn't too far off. And there's some very key and specific drivers for these changes. From the business side, the end users want lower OpEx and CapEx. They want faster time to revenue. They want more flexibility. Then the customer drivers is they want lower downtime, increased output and yield, interoperability for the best of breed solutions from their suppliers, increased flexibility and portability. And as we connect all these devices to the network, they must have security. And once again, this is very similar to the telecom changes, and convergence will power this transformation. So this is a very similar graphic. And we're moving from this notion of proprietary, specialized, and monolithic solutions for all of our manufacturing devices, programmable logic controllers, human machine interfaces, robotics, manufacturing video, to virtualized, open, and interoperable solutions. Everybody, a common phrase is, if you want a new function in your factory today, you need to go out and buy a new box and put it in your factory. What we're moving to, though, is off-the-shelf hardware running in a local data center or on-premise data center with virtualized applications and software decoupled from hardware. If you want a new function in your factory, you're going to be able to buy a new application, install it, and run it. So Mary mentioned Don Bartusiak, and coincidentally enough, I work with Don quite a bit, and so does Darren. And I have a quote here from ExxonMobil. I'll read this. ExxonMobil is looking for a step change improvement to industrial control systems of a magnitude that we have not seen since the 1970s. We believe that the transformational change from proprietary systems to open, interoperable ones are analogous to what has occurred in information technology, avionics, and telecommunications is the path to success. Don is a chief engineer for process control at Exxon. And I believe this quote summarizes the need for change from proprietary systems to open and interoperable solutions. One of the most important aspects of the statement is that we have undergone this transition in other industries, and those learnings are going to help us in industrial IoT. The question is, how do we move from where we were and where we are now to where we need to be in the future? And the answer, from my opinion, from Darren's opinion, and what the industry is driving and what other industries have done, have been based in industry collaboration. And that collaboration mostly materializes in two forms. Industry standards, where companies and competitors get together and collaborate to develop common specifications and interoperability, and also open source projects, where developers get together and collaborate and develop common code for the industry. So the next 4 slides, I'm going to get into a lot of detail. I'm not going to be able to cover all of it, but this is a glimpse into what Darren and I do on a daily basis. The first is looking at the industrial IoT, really an IT and OT standards and consortia landscape. When we look across the world, it's a very complex ecosystem, and we've attempted to simplify it here. One, we've split this into a 2x2 graphic, OT and IT on one side, and China versus the rest of the world on the other side. The consortia across the top are mainly attended by what we typically see as technologists coming from the IT domain. They understand internet technologies. These are the common technologies that we're seeing today with our PCs and laptops and communications. Within China, there's a lot of specific entities driven by private and government industries. Alibaba has ICA, which is the IoT Connectivity Alliance. Huawei has ECC, which is the Edge Computing Consortium. And then some government agencies, MIIT and CAICT, drive a consortia, which is AII. And then in the USA, Japan, and Europe, there's a couple of different major consortia. I think a lot of us have heard about Industry 4.0, and this is primarily driven out of Europe and the manufacturers in Europe. In the US, we have the IIC and OpenFog, which is the Industrial Internet Consortia, which just, within the last year merged with the OpenFog Consortia. This was driven by companies like Cisco and GE and Intel. And then Huawei is also, before the recent pandemic and some of the global trade issues, was forming a ECC Europe with some partners in Europe. There's also some common things like W3C and IETF that have been around for a long time, and they've been working on web technologies, networking technologies. And then was a consortia that was started about 3 or 4 years ago that was a combination of groups that Intel, Samsung, Microsoft, and Qualcomm were driving that merged together. Now, these 3 groups have come together to work on with an organization called One Data Model, which is really trying to address the definition of data models and information exchange. Now, if we drop down below in the OT environment, some of the groups you see here are standardized but operate independently and don't interoperate. And these are networking technologies that grew out of necessity because there weren't any standards available. So you see, in what are common in the operating or in the manufacturing space are these field bus protocols such as Profinet, Ethernet IP, CC-Link, and EtherCAT. There's probably 50 to 100 more different of these field bus technologies. How we've evolved is we've tried to, and we are driving some of the structure around standards that are being driven from the OT world And we're bringing these into the OT domain. Within the open group, there's an organization called the Open Process Automation Forum. And in the tech space, we love our acronyms and then developing new words. So we call this OPAF. And this was an effort that was actually driven initially by Don Bartusiak and ExxonMobil. And OPAF was created as an organization that was intended to be a standards of standards. They wanted to reuse existing standards and pull from the IT domain if these standards already existed. And then they would develop and collaborate to develop or to fill any gaps that existed that the current standards didn't address. So OPAF is focused on connectivity frameworks, information models and configurations. The security is at the top and very important, obviously. OPAF has developed a manageability framework so they can manage and move applications throughout their facilities and factories, developing technical architecture specifications, and also working on standardizing aspects of the physical platform. What's critical in all this and down below is interoperability. You know, when we have all these devices, all these data models, all these different information models, how do we make it so that these are all interoperable and interchangeable like Lego pieces? And a lot of that effort and the foundation of that has to be in the connectivity framework. And this also addresses the fragmentation, or is attempting to address the fragmentation that we've seen in the field bus space. The connectivity framework within OPAF as a standards of standards, we point to the OPC Foundation's Unified Architecture Group. And then within the OPC Foundation, we developed a new group called OPC Field Level Communication Group. And the Field Level Communication Group is about 40 to 50 companies in the industry that are all trying to solve issues around conversions and interoperability and the communication space in factories. How do we get all these devices all speaking the same language? And I'll try to explain this, but where we're focused is on a core set of technologies driven by the IEEE and IEC. These are major global standards consortia that develop specs. And within the IEC, IEEE 60802, we're taking some core specs and we're developing a communication profile for industrial manufacturers. The communication profile is commonly referred to TSN, and this stands for time-sensitive networking. If you can imagine products flying down the line in a factory and machines all dancing in unison to create these products, these all have to be time coordinated. And this is what we're attempting to standardize and converge from all the existing proprietary field buses that all have time sensitivity built into them, but in a very proprietary way. There's a core set of TSN specs, and these specs and these solutions have to work over multiple transports. They have to work over Ethernet, they need to work over Wi-Fi, they need to work over 5G. And then the IETF is helping us as well because we need to do this time coordination over different subnets as these packets traverse the factory floor to the on-premise data center to the cloud infrastructure and back. And then all of this needs to be certified so that it works together. In my past, I sat on the board of directors for the Wi-Fi Alliance, and this was a very similar structure. The IEEE defines the 802.11 standards for Wi-Fi that we all know and love. There's a lot of interpretation to these standards, so the Wi-Fi Alliance was created to make sure that there were interoperability events and programs and specs, and a certification program that manufacturers submit their devices to, so that if the devices comply, you and I and everybody else can buy any certified device we want, and we can walk into any facility or coffee shop around the globe and our Wi-Fi works. This is the same thing we need to do in industrial, and why certification is important. You know, end users like Exxon need to be able to buy devices from any supplier they want, take it down into their factory floor, install it, and have it work without any major hiccups or problems that need to be solved. Now, this is a complex environment for the standards world. Even more complex is the open source software ecosystem for industrial solutions. Open source hasn't been typically used, it hasn't fully been embraced by industrial manufacturers, but this is a growing aspect of industrial solutions in the future. I can walk through this a little bit. Up above, there's two major foundations that we at Intel work within and help facilitate. They're the OpenStack Foundation and then the Linux Foundation. And with the OpenStack Foundation, we work on technologies like the Starling X project and then Kata Containers project. And this is really developing some basic infrastructure for manufacturing environments. Likewise, there's some container projects and other initiatives within the Linux Foundation. And this is a matter of preference for a lot of manufacturers, and we invest in both. There's also a new project in the Linux Foundation called LF Networking. And again, these are some core and foundational projects around network function virtualization and software-defined networks like we saw in the telecom space. And then there's also some additional projects about accelerating packets and optimizing switches. Security is important, and they're in functional safety, and the ELISA project is focused on safety critical Linux. There's projects like the Open Manufacturing Project, where cloud service providers and end users are getting together to define how clouds can interact and ingest data from manufacturing floors. There's blueprint projects like LF Edge, which takes a lot of different projects and tries to define how they come together and work together. And then there's additional real-time safety, critical lightweight virtualization projects. And then as you know, these technologies need to work between the factory floor and the cloud. There's some additional cloud-based edge projects that are being developed to help manufacturers and technology providers. There's a lot of robots, obviously, in factory floors. Open Software Robotics Foundation, ROS, ROS2, ROS-I, these projects have been in existence for a long time. And now we're integrating these into the other technologies, communications, and operations in the factory. Additionally, there's some projects that are single company governance. Like if you're familiar with open source, a lot of it is based on meritocracy. Many different developers are involved. And it's democratic in the sense of developers are managing and collaborating together to make decisions. The projects that I'm highlighting right now, these are more single company governance projects. It doesn't mean they're any better or worse. It just doesn't have the same level of meritocracy across the industry. OpenPLC has been around for a long time. Open 62541 and OSADL is taking, I mentioned in the standard space, we're developing specs for OPC Foundation and time-sensitive networking. This is an open source implementation of those standards, and there's a few more here that you see. Project Haystack is one of the last ones that I'll mention, and again, this is a project that looks at data semantics and interoperability. This is defining common data models. And what I mean there is, you know, how many how many different ways are there to describe a light bulb or a light switch in a factory or a commercial building or even a consumer's home? We probably don't need more than one or two, but we have hundreds of ways to describe something as simple as a light bulb or a light switch. And Project Haystack was developed to try and address that. And then at Intel, one of the things that we drive and have seen a lot of success in is an OpenVINO project. This is around deep learning inference and a training engine. And we've seen deployments all over the world and a lot of adoption of this open source project. Very complex environment that we operate, both in the standards world and the open source world. And the complexity and the sheer number of organizations means that we invest heavily in attendance, in developing specs, and developing certification programs, ensuring interoperability, lining up releases, and then in the open source space, applying our developers to actually develop and contribute code. We develop internally, we upstream it to projects. We also pull from these projects and develop commercial solutions or work with our industry partners with commercial software products and help them. At the end of the day, this all has to come together in products that we deliver to the marketplace. And this slide is intended to simplify things and show how our goals and business objectives are met by particular aspects of standards bodies or open source projects. So when we talk about workload consolidation, taking things off a bunch of fixed function devices and moving them into virtualized environments on common off-the-shelf hardware, this is driven primarily in the work we're doing in the open process, our automation forum, OPAF. And then I mentioned, the field level communications with the OPC Foundation and their field level communication group is defining common ways to network and share information from the factory floor all the way to the cloud. In the time sensitive networking space, I've mentioned IEEE, there's 802.1. 60802 is the industrial profile, and Avenue is an organization that has done a lot of certification already in the time-sensitive networking space across automotive and pro and consumer AV, and we're bringing that experience to help us with certification in the industrial space. All this has to run across transports, whether it's wired with Ethernet or Wi-Fi with the Wi-Fi Alliance and 802.11, or in the emerging 5G space with 3GPP and then 5G ACIA as the industrial aspects of 5G. We can't forget about the existing and legacy field buses, and those have to be incorporated, especially, some of these are going to continue to live on in environments, and transitions are going to happen over a long time. And the work we're doing in IETF with DetNet and RAW and IP networking is going to help with this transition from these legacy field buses to a more common communications framework. And then we layer in our open source, and this is intended to line up. So in the TSN space, we're working with the core Linux kernel and the Open Avenue. And then OSADL is an open source project that we're investing in that takes Open Avenue, the Linux kernel, and Open 62541 to help deliver the time-sensitive networking solution code base that the industry can adopt and help them transition their products. We have the EdgeX project, a Crano time-critical blueprint, and Starling X, all developing and delivering code for workload consolidation, virtualization, containerization, and adhering to the existing industrial standards like ISA 95. And then Acorn is an open source project that's focused on a real-time virtualization. So this is a high-level simplification and blueprint of all the standards activities across the globe and all the open source projects that are in existence and how we at Intel in our Industrial Solutions division are looking at applying to our products and products with our fellow travelers and customers. I think we're a little ahead of time, but in summary, this fourth industrial revolution, it's happening now, and it's following the similar types of transformations that we've already seen in other verticals. I walked through the telco example. All the industrial equipment that is being built today is in various stages of being delivered, connected, smart, and autonomous. Standards and open source software are key drivers. We've seen this in other verticals. We've seen this in consumer products. We've seen this in commercial products. This isn't anything new or revolutionary in and of itself, but a lot of common and interoperable standards and the adoption and utilization of open source software is still fairly new in the industrial segment. And we're committed to driving that change in the industrial segment like we've seen it driven in other segments. And the ecosystems are complex. The changes that we're talking about aren't going to happen overnight, but the business and customer drivers are too critical for these changes not to happen. Charles, Mary, Darren, we're to questions if there are any.
Sure, got a couple questions here for you. So how has standards influenced markets to change or adjust in the past?
You know, it's a complex environment. And if, you know, my family or friends ask me, you know, Gary, what is your job? And the best way that I've found that I could describe it is I'm a technology diplomat. Standards change markets through diplomacy. You have a group of competitors, you have various upstarts and disruptors, you have industry stalwarts that all need to come together and negotiate and agree on common solutions. They need to draw a line of everything above the line, we're going to freely compete. Everything below the line, we're going to standardize and agree to do the exact same way. The reason that they do this is because it's been proven that standards rapidly grow markets. From an Intel perspective, we don't have a hidden agenda. Our goal is to rapidly expand markets, rapidly advance technology, let sockets proliferate, and then we go compete with our competitors for those sockets. So standards is really about, and open source is really about removing friction from markets so that those markets can rapidly expand and grow.
Yeah, and Gary talked about some examples in his presentation around telecom and those kind of areas. I think the standards allow end users to influence kind of what's happening, or even, you know, participants in the market where it's just either inefficient for various reasons because people are doing it over and over again at each company and it really isn't a differentiator, or where there is sort of a stalling of innovation because everything has to be done by each individual company as opposed to a common platform. You know, think about how, you know, different how your cell phone would work if there wasn't sort of a common standard that goes across, you know, all of those areas now, right? You'd only work on the towers that were particular companies, like whenever it first all started, and, you know, there wasn't a sharing and expansion of that, and it forced kind of the data expansion when the iPhone came out, forced a lot of that to happen to be able to actually keep up with that amount of data and expansion that was required for that kind of a network.
All right. Another, oh, sorry, Mary, go ahead.
I wanted to continue that conversation just for a moment because, you know, what you were talking about there, Darren, was, you know, really transformative to our world as a consumer, you know, so I want to link this to personal experience because I think it's related to what's happening in the world of physical assets now inside the manufacturing world. So I'm wondering, can you comment on the cultural issues? What are you seeing out there? Certainly you're working with only, the most leading industries and companies, but beyond that, what's your feel for the temperature of the market, relative maturity of digital density, et cetera, things like that?
I'll let Gary answer too. I think there's sort of two pieces to that. I mean, there are a lot of people that are interested. They've gone out and they've done some testing of the waters and they've seen the benefit. And so I think we're right on the cusp of adoption of people wanting to be able to implement, first probably a common data structure. So right now they've implemented a bunch of solutions across any given factory that don't talk to each other, and so it doesn't share information from one place to the other very well. And so from just a data perspective, I think there's a good starting point there. And then secondly, actually, the other thing we've heard is, with the current situation and the virus having factory owners having to do a lot more remote work and control their factories with less people and keep them farther apart, they've kind of said, hey, well, look, we actually had to do our pilot now because we were forced to do it. And the reality of the situation is, now that we've done it, be it with piecemeal and duct tape and baling twine, if you will, we'd like to not go all the way back to what we were doing before and start incorporating more of these things. And so we need, they're asking for solutions faster than we probably would have anticipated before this hit, because effectively they probably would have done pilots for a couple of years and deployed, but out of necessity, they had to deploy solutions that are kind of like what is being proposed in industrial now, but they had to do it in a fast way that wasn't necessarily kind of as robust as maybe they would prefer. And so I think they're asking for those commercial solutions now.
All right. Our next question, what standards are evolving around the industrial markets?
Yeah, I think we walked through some of those. The Process Automation Forum is really a collection of suppliers, end users, technology providers, primarily in the process automation space. The technologies that are going to be developed here can also easily apply to discrete and hybrid manufacturing. Communications technologies are critical to provide the foundation for these devices to communicate and interoperate. The standards around data models and information models are going to help with the ingestion and the analyzing of the data. And then, the core networking technologies, industrial Wi-Fi, Ethernet, two-wire Ethernet. And we're going to see a major change with the advent of 5G. And admittedly, 5G at times, probably more often than we desire, can be overhyped. But the changes that 5G is going to bring to the manufacturing and industrial environment can't be taken lightly. You're going to have the ability where manufacturers can have private 5G networks for their factory or their systems of factories that they can operate themselves, or they can hire someone to operate for themselves. You're going to see a massive amount of data that can now be collected and analyzed. If you think of one example is within a factory, the sheer expense of pulling wires through a factory is way too prohibitive to instrument every single machine in the factory. But with wireless technology, you can start putting sensors all over your machines, heat sensors, humidity sensors, vibration sensors, and all that data can now be transmitted wirelessly to a data center and analyzed. And now you can start correlating failures with conditions in that manufacturing environment for your predictive maintenance. So when we talk about, what are some of the technologies in the industrial space or some of the standards that are going to be revolutionary, wireless and 5G is one of the key ones. And then, as we went through the presentation and walked through the steps with the Process Automation Forum, the OPC Foundation, Avenue Alliance, and all the core networking technologies, those are all the areas that we're standardizing for industrial.
Do you see any way that those standards will shape what happens with 5G?
The way that those standards will shape what happens with 5G. Yes and no. Primarily when we talk about time-sensitive networking, I think that's one of the spaces where, I mentioned technology diplomacy, is we're going to have to negotiate and we're going to have to develop solutions that are interoperable for data models and packet timestamps across 5G and Wi-Fi and wired networking. And so there's going to be some back and forth about how those different transports will shape the specifications and implementations of each other. And then as we get into the smart and autonomous portions of this fourth industrial revolution, and real-time calculations are going to be critical. We're going to see more overlap and need to collaborate with these networking technologies and the hypervisors and the containers and the ingestion engines. So yeah, I can't point to specific core pieces of technology that are going to have to change. I think in a lot of ways, in a lot of regards, it's going to be, how do you optimize? Now that we have these core standards, we have these core 5G standards, we have these core workload consolidation standards, functional safety standards, how do we now optimize for the networks and the transports such as 5G? And vice versa, how does 5G optimize for the workload consolidation, functional safety, virtualization technologies?
Awesome. Mary, do you have any additional questions for Darren and Gary?
No, I don't. I think this has really been insightful, and I have really learned a lot from hearing from you, Gary. Thank you so much for contributing this knowledge for us today. It's going to become part of our body of knowledge, and it will be, I'm sure, referenced many times by people who are traveling a similar journey through the industrial IoT, right? Because each one is an individual project, as we all know, right? So anything we can do to help, it just furthers our world, I think, as a whole. So thank you very much.
You're welcome. Again, I'm very happy to be here.
Yeah, thank you for the opportunity, Mary.
All right. Well, that's all the time we have today. Thank you, Gary and Darren, and all our guests for your great questions and active participation. We'll be posting the recording from today's session on the CSI website events page. You can access it there shortly. I'll invite you to tune in on Thursday, June 4th, when we'll hear from Dr. Nicole Taukis. While sustainable and organic agriculture is often viewed as a return to traditional practices, in reality, these new management practices represent a positive progression in food production and land management. However, they also encompass and often require the application of heterogeneous materials or practices. Historically, this complexity limited the area across which these management types could be deployed. However, increasing demand for sustainably grown food is requiring larger land footprints for these practices. Technological tools and solutions are not only desired, but required to enable the production of healthy food with the least amount of chemicals and environmental impact possible, while maximizing the quality of food products and rural livelihoods. Sustainable and Organic Agriculture, Opportunities for Technological Solutions, an hour-long webinar brought to you by the UWM Connected Systems Institute. Please register for this event at uwm.edu/CSI/events. My name is Charles Mosley, your host, signing off for today. Thanks for attending.
Thank you, Charles.
Thank you.